In this video, we will be talking about the IUPAC naming of alkane, alkene, and alkyne. So just to dissect the video, we will be we will be tackling part 1 of this topic. Part 1 will consist of the lecture and part 2 will consist of the practice in regards to the lessons that we will have learned in this video. So you will have to wait for part 2 for the next upcoming video. So without further ado, let's start. So first we have hydrocarbons, a combination of H and C, hydrogen and carbon. So it's said that there are two types of hydrocarbons. We have the aliphatic hydrocarbon and the aromatic hydrocarbon. For now, we're going to focus on the aliphatic hydrocarbons, particularly the alkanes, alkenes, and alkynes. We will disregard in this video the topic about cycloalkanes. That might not be tackled in the future videos. Our school never taught us that part of this lesson. So you may refer to other more professional videos in regards to the study of cycloalkanes. I myself haven't studied about it yet, but if your school is tackling about this lesson, you may proceed to watching other videos. For this video, we'll only be talking about alkanes, alkenes, and alkynes. Now, let's proceed. So, for the definition of aliphatic hydrocarbon, alkane, alkene, and alkyne are just some of the members of this hydrocarbon group. And aliphatic hydrocarbon is a long chain of hydrocarbons. As for aromatic hydrocarbons, they have three characteristics. They are cyclic, they produce resonance, and they have double bonds. When I mean double bonds, we'll be tackling about double bonds in the next part of this lecture. So that double bond represents two lines that are in sync or are parallel to each other. So let's first talk about the single, double, and triple bonds. So for alkane, the one with A and E, we have a single bond. For alkene, with the E and E as a suffix, we have a double bond. As for alkyne, Y and E as a suffix, we have a triple bond. So it's best to take note of that. Alkane, single. Alkene, double bond. Alkyne, or Y and E, triple bond. So for example, provided that we have this figure over here, a hydrocarbon structure, this zigzag line over here will be our parent chain. We'll be talking about parent chain in a few seconds. For now, let's just assume that this is the parent chain as it is, and this is going to be another line. Assume as if for a tree we have a branch. So just assume that this is going to be our parent chain and this is going to be our branch, which is, in this lesson, it's going to be called the substituent. That will be also discussed in a few minutes in the next page, this one. So let's try to avoid confusion. For now, let's just understand that every point that we can make here is a carbon. So if we count it, if we count the points of the segments, 1, 2, 3, 4, 5, 6, we have 6 carbons. And actually, we'll be talking about that later also. For now, let's just understand that the zigzag line doesn't have any double bond or triple bond. As you can see, the line doesn't have any thing like that or like this. So yes, the parent chain has a single bond. Therefore, we will have the suffix "ane" as the IUPAC name. So that is just one clue in naming the IUPAC name of this hydrocarbon structure. So let's move. For the definition of parent name, this is chosen according to the hydrocarbon's functional group hierarchy. When a hydrocarbon structure is branched out, as you can see here, it's branched out properly, we have to consider the amount of carbons in the longest carbon chain as the parent chain. So the definition says about the longest carbon chain as a parent chain. So the longest, as you can see here, is the zigzag line, not this one. It's just a single line. So considering that this is our parent chain, we are to count the number of carbons or the amount of carbons. And yes, the statement that I have said a while ago, 6 carbons, that is everything that is being talked about earlier. So we just recently counted how many carbons this parent chain has. So 6 carbons. So you might be asking right now, what is the purpose of counting the carbons? Well, in this list, this is a big list, by the way. This is where the number of carbons matter. As you can see, for every amount of carbon, there is a corresponding prefix. And with the corresponding prefix, we have to count the number of bonds. So earlier, it is already understood that single bond refers to AN, or in other words, ANE, because hydrocarbon, the suffix E already goes for all. Regardless of the number of carbons, the very suffix at the end will always end with E, whether it's a single bond, ane, ene, or eine. So yes, for double bond, it is understood that we have E and E. Triple bond, it is understood that we have Y and E as the suffix. So considering that we have 6 carbons, the prefix says for 6 carbons we have the prefix hex. So yes, let's move to the exam continued solution here. So we know that we have 6 carbons, therefore we have hex. And now we do have a branch. Earlier we talked about comparing this complicated structure. Actually, it's not really that complicated, but for a student who just saw this lesson recently, who had no experience whatsoever, this lesson may be difficult. But explaining this in layman's terms, you can compare this complicated structure in a beginner's mind perspective to a tree, a basic tree. This is going to be the parent chain, and the branch will be the substituent. So for the substituent, we could count that we have 1 carbon. So this is a new word for those who haven't learned about this lesson yet in the past before watching this video. Methyl. There is also a table for substituent, which is this one. So earlier we talked about the parent chain table. So this is how we classify. This is how this is the table that we rely on in order to analyze what we have in the parent chain. In other words, classifying the number of carbons according to their corresponding prefixes and suffixes. So it is understood that the substituent is also single bond. There is no double bond nor triple bond. So now you might be wondering, we have already tackled about the substituent. Let's go with the definition. The substituent is attached to the parent chain. So again, like a tree, a branch is attached to the tree. A substituent is attached to the parent chain. And it is going to be named differently. Just like an independent country, the country will have its own constitution and its own government. So it will be named differently. The substituent has its own table of classification. And earlier, you've seen that 1 carbon is equivalent to the prefix methyl, or I'm not sure if it's a prefix or suffix, but it's a keyword in order to that will aid in your classification of the IUPAC name of the hydrocarbon. So, one carbon is equivalent to methyl, two carbons equivalent to ethyl, three carbons equivalent to propyl. Now, to illustrate, this is a different example. So, provided you have this zigzag, that is going to be your parent chain. And for methyl, assuming you just have one branch, so this is one carbon. For ethyl, assuming that this is a structure, this is not to scale, nor is it maybe it's not really official. I just made it up, but as a branch, so we have two lines here combined with each other. We have two carbons. This substituent is classified as ethyl. So for propyl, let's have another zigzag here as a parent chain, and 1, 2, 3. So 1, 2, 3, 3 carbons. This is an example of propyl as a substituent. So let's go back to our definition. It will be named differently. There's another set of naming rule, which is basically this one. For alkane, alkene, and alkyne, we'll always be using the prefix YL. I'm not sure why the book says we're supposed to use YL is a prefix when it's actually a suffix. Maybe I may be wrong, I may be right, but it's up to you for the audience to analyze. But still, it is understood that we have YL at the end of every part of the substituent nomenclature. So we have meth-il, eth-il, and prop-il. So YL always at the end, because in this video we're only going to tackle about alkane, alkene, and alkyne. So in front, the number in front of the substituent name indicates the position of the substituent in the parent chain. At first, to my own experience, this instruction was actually a little confusing, so let me elaborate this to you. The number in front of the substituent name, basically, if earlier we did number the amount of carbons we have in the parent chain, and to where the substituent is located, where it's nearest to an edge. So right now in our example, the substituent is located near at this edge, not here. So in that case, it is understood that if we number the carbons 1, 2, 3, 4, 5, 6, this point over here that connects to the substituent is going to be the number that's being discussed in this instruction. So let's just undo those unnecessary annotations. So for number 2, we'll just leave 2 here. That's going to come in handy later in the naming of the hydrocarbon structure. So provided that we know we have 1 carbon, this is methyl. We have 6 carbons, we have the prefix hex, and it's understood that this structure is a single bond, so we have A and E. Let's all highlight them. So hex, ane, methyl, and the 2. So if we combine them all together, of course, we'll always have to prioritize the substituent. So substituent at the first part of the naming and the parent chain at the second part, or the last part. So we'll be naming 2 here, the 2 that we got from the structure earlier. And because the substituent has only 1 carbon, we place methyl. So 2-methyl, then place a dash to signify the introduction of the parent chain. We will place the prefix hex, and for the single bond, we place ane at the end. So the IUPAC name of this hydrocarbon structure is titled 2-methylhexane. It's going to be a little complicated at first, but you'll have to squeeze all this information in your mind. And yes, with that, you will consolidate the information that you learned just now, the general instructions when we tackle the practice questions. By the way, I hope you will be frank with yourself. You will not see the answers before you will not see the answers just in order to solve. Of course, that's not practice. So in the next video, we will be tackling practice questions. Please be frank to yourself so that you can always be able to succeed in the lessons that you're learning, especially now that this lesson is not to be um, laughed about. This is a serious lesson. Um, yeah, that's everything that I have to say right now. I'll wait for the part 2 of this video. Thank you for watching.